Hello viewers, I am Tania Gupta in Electronics and Communication Department in ABES Engineering College, Ghaziabad. Today I am going to discuss about the data transfer instruction of 8085 microprocessor. In the data transfer instruction basically includes the transfer of the data from one point to another. It may be the transfer from register to register, register to a memory, memory to a register, but memory to the memory data transfer directly is not possible with any instruction. The data transfer instruction which includes in 8085 are MOV move, MVI, LDA, STA, LHLD, SHLD, LDAX, STAX, LXI and XCHG exchange. We have to discuss these instructions one by one. First of all, very first most data transfer instruction is move, MOV. The mnemonic for this instruction is move, MOV. This instruction basically includes the transfer of the data from one register to another register, one register to another memory location and one memory location to another register. The first type of move instruction is move RD, RS. What does it mean? RD is here destination register, whereas RS is your source register, means the data is transferred from source register to the destination register. These registers may be the register A, register B, register C, register D, register H, L. These all registers are of 8-bit register. These register we can move any data and from any register to another register. For example, if we write move H, A, in this the content of accumulator, the content of a register A is moved into the H register. This is basically a move instruction. This instruction belongs to a register addressing mode. In the register addressing mode, because here the data transfer, data movement is possible within a register, that's why this instruction belongs to a register addressing mode, and this instruction is only 1 byte instruction. What does it mean? That means this instruction takes only one memory location whenever we store this instruction into a memory. This move instruction, here the content of accumulator, whenever the content of accumulator is copied into the H register, basically the content of accumulator and H register both are same. For example, before the execution of move instruction, the content of H register is 42H and the content of accumulator is 59H before the execution of this instruction. After the execution of this instruction, the content of H register is 59H and the content of accumulator is also a 59H. That means this move instruction is nothing but a copy instruction. The content of both register after the execution of this instructions is same. That means move instruction is here misnomer. Basically these are the copy instruction. Second type of move instruction is move M, RS. What does it mean? The content of source register is moved to the memory location which is pointed by HL register pair. For example, you have an instruction move M, A. In this, the content of accumulator is moved to the memory location which is pointed by HL register pair. For example, the content of accumulator before the execution of instruction is 42H. Content of H register is 59H and content of L register is 00H. After the execution of this instruction, After the execution of this instruction, the content of accumulator, this accumulator content 42H is copying to the location 5900H. That means the 5900H location content is now 42H. This is the memory location which is pointed by HL register pair. This instruction again belongs to a indirect addressing mode and 1 byte instruction. Now the third type of the move instruction is move RD, M. What is RD? RD is your destination register. These register is any of these register A, B, C, D, H and L. These are 8-bit register. And M is the memory location content which is pointed by HL register pair. That means this location content which is pointed by HL register pair is moved to the destination register. For example, if we write move B, M, now the content of memory location which is pointed by HL register pair is moved into the B register. This instruction belongs to indirect addressing mode and 1 byte instruction. This is all about the move instruction. Move instruction is of 3 types. Move register to register data transfer, register to a memory data transfer and memory to a register data transfer. Now the next type of this instruction is MVI. MVI stands for move immediately. The format for this instruction is MVI register, destination register, 8-bit data. In this instruction, 8-bit data is mentioned within an instruction. Which 8-bit data is moved into the register is mentioned within an instruction. The 8-bit data range is 00H to FFH. Means from 00H to FFH, any data is moved into the 8-bit register which is mentioned in this instruction. For example, if we write MVI B, 49H, H stands for hexadecimal. These all are hexadecimal numbers. 49H, this 8-bit data is immediately moved into the register B. This instruction belongs to a immediate addressing mode and this instruction is of 2 byte instruction. 1 byte is for this mnemonic and 1 byte is for 8-bit data, means 2 byte instruction and belongs to immediate addressing mode. This is a MVI instruction, MVI RD, 8-bit data. Now the second type of this MVI instruction is MVI M, 8-bit data. Here the M is the memory location content which is pointed by HL register pair and this is the immediate 8-bit data which we have to move into the location. For example, if we have MVI M, 49H. This 49H data is moved to the memory location pointed by HL register pair. This instruction again belongs to immediate addressing mode and 2 byte instruction. After the execution of this instruction, the content of the location is changed which is given in this instruction. Now after the move and MVI, we have third instruction is LDA. LDA instruction is basically a load accumulator. The format for this instruction is LDA, then 16-bit address. 16-bit address, what does it mean? The content of this memory location is loaded into the accumulator. For example, if we write LDA 5000H, after the execution of this instruction, the memory location content of 5000H is loaded into a accumulator. The content of accumulator after the execution of this instruction is the content of this location. For example, the content of memory location 5000H is 42H. After the execution of this instruction, the content of accumulator is 42H, means this data is transferred over here. This instruction is a 3-byte instruction. And direct addressing mode. This instruction belongs to a direct addressing mode and a 3-byte instruction. Now the next instruction is STA. What is STA? STA is a store accumulator. Store the content of accumulator to specified memory location. For example, the format for this instruction is STA, then 16-bit address. After the execution of this instruction, the content of accumulator is copied to this 4000H memory location. This is again a direct, belongs to a direct addressing mode, and this instruction is of 3-byte instruction. This is all about STA. 3-byte instruction belongs to direct addressing mode, used to store the content of accumulator to the specified memory location. Next instruction is LHLD. What is LHLD? LHLD is load HL pair, directly. What does the mean of this instruction? The syntax for this instruction is LHLD 16-bit address. In this, the content, this is basically used to load HL pair with the content of this address which is mentioned in this register. Is this instruction, for example, if we write LHLD 2003H. Now, after the execution of this instruction, the content of 2003 memory location is moved into the L register, and its next location 2004 memory location content is moved into the H register. This instruction belongs to a direct addressing mode, and this is 3 byte instruction. 2 byte is for mnemonic and 1 byte is 1 byte is for mnemonic and 2 byte is for 16-bit address. Next data transfer instruction is SHLD. What is this SHLD? SHLD is store HL pair directly. The syntax for this instruction is SHLD 16-bit address. This instruction is used to store the content of HL register pair to the specified memory location. For example, if we write SHLD 5000H, now the content of L register is moved into the 5000H memory location, and content of H register is moved into the next memory location, which is 5001H. Means the content of L is copying to the 5000H and the content of H register is moved into the 5001H. This instruction belongs to a direct addressing mode. And this instruction is 3 byte instruction. Means whenever we have to store this instruction into a memory, it takes 3 bytes, 3 memory location to store this instruction. This is all about SHLD and LHLD. Now the next type is LDAX. What is LDAX? Next data transfer instruction is LDAX. LDAX stands for load accumulator indirectly. This instruction is basically used with register pair. This is the syntax of this instruction. What does it mean? That it is used to load accumulator with the content which is specified by BC register pair. These are the register pair which is used in 8085 microprocessor: register pair BC, register pair DE, register pair HL. But in this instruction you have to use only BC register pair and DE register pair. HL register pair is not used in this instruction. For example, before the execution of this instruction, the content of accumulator is 49H, content of B register is 42H, and content of C register is 50H, and the memory location content which is pointed by BC register pair 4250 content is 59H. This is the scenario before the execution of this instruction LDAXB. Now, after the execution of this instruction, the content of accumulator is changed to the 59H. How? This is the content of this location. Now this instruction is used to load accumulator with the content which is specified a memory location which is given by BC register pair. 4250 memory location content 59H is loaded into a accumulator after the execution of this instruction. But the content of register B, register C and the memory location is not changed, but this instruction is only used to load the content into accumulator. This instruction belongs to a indirect addressing mode and only 1 byte instruction. Now the next instruction is STAX. Next data transfer instruction is STAX. STAX instruction is used store the content of accumulator. Store the content indirectly. Store the content of accumulator indirectly. This is just opposite to the LDAX. The syntax for this instruction is STAX RP. What is RP? RP is a register pair. Here, for example, if we write STAXB, now this instruction store the content of accumulator to the memory location which is specified by BC register pair. Now for example, if we consider the same example, the content of accumulator is 49H, B and C register is 4250 and the content of this location is 59H. Now what happened after the execution of this instruction? Now this instruction is used to store the content of this accumulator to the memory location which is pointed by BC register pair. Now after the execution of this instruction, the content of accumulator is same 49H, but the content of memory location 4250H memory location content is changed to the 49H. This instruction again indirect addressing mode and it is only 1 byte instruction. This is all about STAX instruction. These both instruction, one is used for loading the accumulator and another one is used to storing the accumulator, store the content of accumulator. Now the next data transfer instruction is LXI. What is this LXI? LXI instruction is used load immediately 16-bit data into a register pair. The format for this instruction is LXI RP, 16-bit data. This data, this RP is maybe BC, DE, HL. It also include SP. SP is stack pointer 16-bit register. For example, if we write LXI B, 4259H, this instruction copies this 16-bit data into BC register pair. Here you have to mention over here is higher order register only. Means after the execution of this instruction, the content of B register is 42 and the content of C register is 59. Means higher order byte is placed into a higher register and lower order byte 59H is placed into a lower register. Next, this instruction belongs to immediate addressing mode and this instruction is a 3-byte instruction. Now the next instruction of data transfer group is exchange, XCHG. The mnemonic for this instruction is XCHG. This instruction is used to exchange the data of HL register pair with DE register pair. Here the content of higher order register means register H is exchanged with register D and the content of register L is exchanged with register E. this instruction is only used with HL and DE, means its operand is fixed, means this in this you have only mnemonic. That's why this instruction belongs to a implicit addressing mode and only 1 byte instruction. This is all about the data transfer instruction of 8085 microprocessor unit. These instruction does not affect any flag of the flag register, means in this there is no manipulation of the data, but the data is transferred from one place to another. That's why in this no flag register is affected in the 8085 microprocessor, means the flags are affected by another instruction like arithmetic instruction, logical instruction, but in data transfer instruction you have no flags are affected and one data is transferred from one place to another place. Thank you.